What does a series converge to? You can expand it, but I don't know if you're going to be able to establish a rule for the nth partial sum. So when our denominator is factored, we might try partial fraction decomposition. So here's the partial fraction decomposition process. We find our a and b. We can rewrite this expression this way. I'll factor out that 1/2, and now expand. And when we expand, don't actually do the subtractions, just leave them written as subtractions. Here we go. So if we expand it, these are the first 7 terms, the first 6 terms, and now we search for cancellation pattern. The 1/1 will never get canceled because the negatives are just getting closer and closer to 0. They'll never approach -1. So 1/1 stays. This -1/5, that does cancel with this positive 1/5. And that was 1, 2, 3 away. This positive 1/3, will there ever be a -1/3 to cancel it out? No, this will never get to -1/3. It's going in the wrong direction. So the 1/3 stays. What about the -1/7? Oh, there's a positive 1/7 right there. And it's 1, 2, 3 away. Okay, how about the -1/9? Oh, there's a positive 1/9 right there. 1, 2, 3 away. And the -1/11, positive 1/11, 3 away. So everybody's going to cancel out. Absolutely, everybody's going to cancel out. There may be some terms left over in the end, which will be the last terms. But as the series becomes infinite, as the number of terms approaches infinity, everybody cancels out except for those last terms. And as n is approaching infinity, those terms are approaching 0. So we're left with 1/2 of 1 plus 1/3, which is a sum of 2/3.